So now we're starting recording. Welcome everybody to the first developer workshop for the hackathon in 2024. My name is Mikey Andersen, sitting here with Scheel. We're here to present how to work on the blockchain as a developer, and mainly showcasing this brand new tool called the Dev Playground that we have developed to make it much easier for you to just start getting something done in the blockchain environment. So Jens, let's get the show started.
Yes, welcome everybody. So first, I'm just going to show you the playground real quickly. So if you go to the GitHub page for the Partisia Blockchain and find the repo Dev Playground, you will see a quick rebrief which will guide you into how to actually boot it up. I also quickly want to show you if you want to try and code along while we're doing the learning challenges. So to boot up a code space, all you have to do is click on the code icon, click here and create code space on main, where you have a GitHub account. It will then set up the code space where it will install all of the tooling needed, the necessary languages, and also helping tools for it. It will also give you an VS Code editor in the browser that you can use to edit your contracts. I will be doing the development locally because that's what I'm used to.
And live.
Yeah, and live. Where I will be just using a clone of the Dev Playground to actually code it. So now it's booting up. I also quickly want to show this. As it's booting up, part of it is actually creating these new keys for you to use on the testnet. So right here, it's not done yet with creating the next key, but you can see here in the account A that we have already gotten our new key, which we will be able to use. Right.
Yeah, so just to elaborate a second on this one. Important thing to do anything on the blockchain is to have an account for the blockchain. This account A is a newly produced one that has some testnet coins already on it. So it's just ready to go. It's a plug and play private key. And this is the actual private key you can just use to generate your public key and start getting anything done with the blockchain.
Yes, exactly. So now I will go over into my editor of choice right here. Oh.
Yeah, so what Jens is saying is that he's taking the Dev Playground, cloning it down locally on his machine, so it just feels better to code on from his perspective. You could use the Dev Playground as it is in the browser itself, or you can do what Jens is doing and having it locally. That's up to you.
I've just cloned it, and then I've stepped into it, and now opened it in my editor of choice. So let's see. So first we have these tutorials that we can go into. So the tutorial here is for the petition example application. What it would like us to do, if we scroll down, is to do the learning challenges, where they will, the first one they would like us to do, where we are extending the contract, is where we are actually setting it so we can only use one of the two accounts to sign our petition by having a constant. So if we go in to the petition contract, we can see here the definition of the petition contract, where we have the state, which is what is on the chain, what is actually safe on chain, and what is can we change with our different actions. So then we have the init action, which allows us to create the first state of the contract when deploying on chain. This is where we would set the description of our petition, like I like cake, a petition I would definitely sign. And then we will also initialize this sorted set where everybody who has signed the petition would be kept in. So that would be the first state. Great. So now we would like to have it so that the only accounts that are allowed to sign is account 1, account A, and account B. So how will we actually do this? So we would extend, one way to do it is by extending our state and holding those two accounts, just like this, for account A and account B. And now we will have to add that to our initial state. So we can just add them as parameters for our init function. Address A, account A. And account B. Great. Now we can just add those two. Boom. And now we just need to assert that the sender of our action when on chain is one of those two accounts that we have set in the initial step. One way to do this is by using a normal Rust assert, where we assert that the context which holds the sender is equal to account of state dot account A, or context.sender.
Yeah, so Jens is trying to achieve just a standard conditional, hey, do we already exist in the state A or B, as these accounts that can actually sign our petition.
Yes. So how would we be able to check that this worked? Well, one of the ways that we can do this is actually by deploying the contract right from our command line. So we have the cargo Partisia tool, cargo Partisia contract, where we can first off build our contracts and check there are no compile errors. Also,
so now we're building the contract. We're using the cargo Partisia contract tool to build the contract, get the files we need to actually deploy onto the blockchain, and using probably, I would guess, the command line tools to deploy the contract directly on testnet. So we can constantly check that what we actually do works on the blockchain and not just something we imagine works.
So now we can use our command line tool, which we can call by having, we can see what the different options are here. So what we would like to do is we would like to send a transaction, and then we can see what the different options are here. So to send a transaction, there we can send an action, we can deploy, or we can refuel with some gas.
Someone is right.
How is
default zero?
All right. Good. So now we would like to deploy our partition contract. So we can call the deploy. And if we again see the code, then we can see that what deploy needs is a public key, a private key that it is using to be the sender. What bytecode file that is. In this case, since it's a public contract, that would be the BASM file. Okay. And we would also need an ABI file, where ABI stands for Application Binary Interface. What that actually means is just a way of telling how to communicate with your contract and how to communicate with different parts of your contract. And then we also need to send the init parameters. In our case, that would be the account that we want to be A and the account we want to be B, and also the description of the petition contract. Okay, so let's try and deploy. So it is located in the target, BASM, release folder. And here you can see that we have our petition contract, ABI, and also the BASM. So we are going to have the petition BASM, and then we're going to have just the same again, but with our ABI. All right. So now we need to give our initialization parameters. So that's a string where I would like to have my petition, I like cake, and the account of A and B. Oh, I've got something. I don't have any accounts since I don't have the code space. So first off, I actually need to do something else.
You need to create an account.
I need to create my accounts. So I can quickly.
So let me explain a bit around while you do it, right? So the idea is that the command line tool can actually do a lot of things for us. And Jens is heavily showcasing that if you actually need an account, you can just ask the command line tool to create you an account, and that will actually fill it up with gas. So you're just ready to go from the start of it. The way you do it is that you write the CLI account create, and then you can do --help if you want to have some of the options there.
So now we're getting an address for our account A. I will also do this for account B. We'll also get gas for it. And C. So now that I have my free accounts, I can now go back and try and do the deployment of it, where I would like to have that account B and C, let's say account A and B, just not to get any abusing, will be used as the only accounts allowed to sign. Now I just need to specify who will be the sender, and in this case, that is my account. Good. So this should give us. Oh yeah. I also need to send along how much gas I would like to pay for it. Gas in this case is going to be 10,000.
Yeah, so the command line tool is designed around the possibilities of getting help every time you do something wrong. So we have now created the deploy of the I like cake petition.
Yes, exactly. I think I'm not sending enough gas. Hey, and there it is. And the neat thing about this is now that we can actually view it in our. Oh, it did open. We can view it in our browser. I like cake. Account A and account B has now been used. So what I can also do now is I can log in as account A. Save. And now I can call the action on this contract that I have deployed and signed the petition. Go to here and sign it. And what we can now see is that in the signed by list, it is actually signed by my account. So if I try to sign it with another account, for example, account C, which was the one we deployed it with, if I sign in with my other key here and try to sign it.
So again, iterating that you can just grab the private keys and you can use them immediately. They have test coins on it. What Jens is showing is that he can't sign it as the account C, since the assert will stop him from doing it.
Exactly.
Hopefully.
Hopefully. So we can see that we send our transaction. We can also see that it failed.
Yes, so the transaction failed. There are nothing to say about it. Okay, I can see it's one of the, so actually it's a browser issue we have, that sometimes it needs to update for a couple of seconds more before the real status is being shown. But if you go to the contract and look at the transaction, you can actually see the correct status of it. So that means the assert has worked. It has not been signed by account C.
Exactly.
It has only been signed by account A in this case. So we have completed the first learning challenge of the petition contract.
Yeah. And it is a different kind of developing than we have previously seen. than there are on many other chains than we have seen. Since we are using this action-based and sharded model, which means that all order of operations are actually executed and they can fail. And when they fail, they are not rolled back. And this is very important because that means that failure can also mean something in the event of, for example, a transfer failing and it not going through. Well, then we need to account for it that it has not happened. If we're expecting a transfer to happen on another contract, we cannot just expect our state not to change, our state to be rolled back when something else fails that we are depending on. We need to make sure that it happened correctly. So yeah, good. So the next thing,
so that was completing one objective of the workshop. Exactly. This is how you could actually develop something. You could build it, you can deploy it, you can get a private account, and all of this is done but from scratch. No homemade cooking, anything, besides knowing some Rust about how to make the assert happen. And now we can actually do a position with the users or the addresses that we know.
Exactly.
And yeah, so that's completing a couple of the first challenges. So what we have with us as the next treat is to actually go in and work with some zero knowledge parts of it. Because the superpower of Partisia Blockchain is zero knowledge and MPC and using that one. And in the tutorial space, we actually have a contract showcasing one of the widely used examples of ours, the average salary example. And that's the next part we'll jump into and try to complete the learning challenge in average salary. So average salary is a contract based around everybody in a company giving in their salary as input, and no one wants to share their salary, but they would love to understand what the average of salaries are in a company without sharing their salary itself. And the first learning challenge is focused around, scroll down maybe a bit, let's jump down to the challenge itself, is to make the zero knowledge computation count how many zero knowledge inputs there are and return that as public available variables. And to kind of say, so if you have a company of 10 people, you would love to understand if 7, 8, or 9, or all 10 of them actually give input to the salary. So you just don't take an average from a bad data inputs, as to say. So the first challenge is about understanding how many inputs did we get to the average salary contract.
Yes, so we can also use them later to actually compute the average of those inputs. So if we go here to our average salary and into our contract, the first thing we want to do is, since the number of inputs are always public, this is not a problem. So we can just count up every time we get an input. So here we have the number of employees, but instead we actually want to count them when we actually are getting the input and not just when we are starting a computation. So right now, this number is coming from when we start the computation. Here we are starting our security computation, where we are setting our number of employees to be equal to the number of secret variables that are currently given to the contract. But instead, we would actually like to be able to calculate the average once again. So that means after we have computed one time, this contract is done. It cannot be used again to compute the average. However, we would like to compute the average every time we get a new employee. So we can add the person to the contract, and then when there are enough new employees and enough of salaries as inputs, well, then we can recompute the average again for our company, and then we, without revealing anything about anyone's salary, we still know the average salary of our company.
So we're changing it from we know how many inputs we will get,
yes,
to we do not know how many inputs we will get to the contract.
Well, it's more in the sense of we want to use the old inputs again in a new computation.
Yeah, okay, in that sense, yes.
So, great. So how do we do this? Well, first off, we need to have this number of employees to be something that we can increment, and it starts from 0. So instead of an option, we're just going to change it to an U32 integer. So down here in the number of employees from the start, there are 0 number of employees who have inputted anything. Good. So what we want to do now is we want to make sure that our state is updated every time we have a verified input. That means an input that is correctly formed that has been sent to our contract. So how do we add it? Well, we add it here into the setk on variable inputted action. This action is called when the node has confirmed that the input is well formed. So that means not only do we know that they send something correct to our nodes, but we also know that they are following, so we can actually compute on the input and get a correct answer.
And we'll talk a bit more about that when we actually deploy it.
Yeah.
It's more visible to
Exactly.
see this in the browser.
Exactly. So first off, I'm just going to add, so it is a mutable state that we're having, so I can actually increment our state. So number of employees is 1. So I am just incremented it, and then I'm returning the state again. Good. So now we just need to check that the number of employees that we actually have are greater than 3. So here we can just insert our state and then use a variable. Good. So now we should count it up every time that we're actually getting an input. So what I want to do here is, again,
and this is a public available counter there is. So
Yeah.
everybody will always be able to see how many inputs, as they also put in the browser itself, but how many inputs will be added to the zero knowledge table here.
Oh, there's an unwrap I have not gotten. So let's see where was it? It was in.
So as expected, when you develop anything, it takes a couple of tries, right? So that's why it's awesome to work. And this would also have been something you would have had in the dev playground from the browser perspective. You would also have gotten the help there when trying to build it. So it's the compiler itself that helps you see what your error is and how you could fix it. It often comes with a good suggestion.
Yeah. This is just warnings about me having a mutable team state instead. So now I'm just gonna quickly deploy a salary contract with this. So I have done this account, but again, it's my deploy action, and I'm using just the other keyword for transaction. Our ZKWA, which stands for zero knowledge vessel. That is when it is a zero knowledge contract instead of a public contract. And then our ABI, and then our public key, which we were using to deploy it, and then how much gas we're sending along. So.
And in general, when doing any zero knowledge contracts, you would need to put in a bit more gas because it is a bit more deploy expensive to do.
Yes.
So that's why you see that Jens has used a lot of gas as well.
Yes.
But on the testnet, we have a lot of gas. So that's not an issue.
So this is our contract. Right now, there are no transactions as we can see. However, we can see that I am the administrator. We have our average salary resolved, which has not been set yet, and the number of employees who have actually entered an input is 0. So if we go back to where we have logged in with our other accounts and we search up our contract, we can see, okay, let's try and interact with it. So I would like to add my salary for as the secret input. So let's just say I make about 550,000. Let's say that. So we add the salary, and now we can see there is nothing yet. But if we update, we can see that the transactions have gone in. So what we can see here is I send in my add salary, which is the action we can see right here. Right here, add salary, that's the action we call to add our input. What happened then is that we sent this input to all of the nodes. all the nodes are now confirming that this is a valid input we sent. Yeah, all the ZK nodes.
Yeah, so that's what we did. So, and yeah, let's expand a bit on the ZK nodes. So whenever you do any zero-knowledge contract deployment in Partisia, you always make like a contract with 4 nodes to do the actual computation for you. And it's because the way MPC simply needs to distribute the secret shares, so they are on 4 different nodes. And simply by having these secret shares on the 4 different nodes, they need to be connected in a network. You need to give some collateral. In the test case, it's just the test MPC collateral coins. But in the real mainnet, you would have to stake some MPC against the deployment of your contract as collateral for these nodes to actually do any computation. And if any of these makes any malicious attempt to get your data, or they're dropped by doing something they shouldn't do, they will always lose the collateral that you have staked towards your worth of the data. So that's kind of how it works. So every time you send any input, you need to send 4 secret shares to 4 different nodes. So one secret share per node, so 4 secret shares in total. And that's what Jens is talking about, showcasing here. He's added 1 input, it goes to 4 nodes, and it simply needs to do that for us to compute on it in the MPC method.
So now that they have all confirmed it, we can now see that we actually have our first added input. So if we go to the state, we should now have an updated number which says 1. So it seems like that we solved that challenge.
Yeah.
However, this number is public. So if I am making averages based on some private information, something like gender, this would not be allowed, because then let's just say I would extend this with a number of female employees, number of male employees. This number would not be safe anymore, since this is private information about the people who are inputting it.
So yeah, we would have to extend the secretness of the variables we actually put in. So number of employees can be a big enough number that's not saying anything privately about anyone. But if you have a company of the same 10 people, and if 3 of these are females compared to the 7 males, it would be much easier to kind of grab personal identifiable information out of these people in our contract.
Yeah.
So to make sure and ensure we don't give anything out, it's on us as developers of the contract to make sure that no secret information is given to anyone in the system itself.
Yes.
And that's the challenge number 2. Let's maybe grab the challenge and just read it for everybody to be on the same level. So what we need to, in the second challenge, is to add a gender next to the secret input and try to branch by using a secret condition.
Exactly.
And branch means kind of like an if statement, if you understand.
Yeah, exactly. It is saying, oh, if it is male, he should be added to the male sum of salaries, and we increment the counter of males who have inputted 1. But we need to do it in secret.
So no one knows it.
Yeah, exactly. So it's all done safe. So how would one go about this? Well, yes. So first off, we need to define an input type such that we can actually define more than just having the salary as an input. So here in our secret input, we have not defined an input type yet.
So what you could do, as I sent the deployed zero-knowledge contract into the chat, is that you could actually go and interact with the contract on the testnet. There are no asserts blocking anyone from adding any input to the zero-knowledge contract. And if a lot of the people here actually goes and input something, I think we'll try and compute the average salary, or at least the average imaginary salary of this room here, and no one would be the wiser of who inputted what. But we could figure out what the average of salaries would be here. So if you want to go and interact with the contract, feel free to add anything into the contract, and let's see how many inputs we could get.
Yes, so I'm just adding the secret type that we would like to be using. So I cheated a little, and therefore I have already defined how this should look, our secret input. So here we are designating it, but we are actually defining it inside our ZK compute file.
And why is that? Why do we have 2 files now in a zero-knowledge contract?
Well, The contract part of it is the public part, the actions where you can interact and where you define how you are handling public information. This is also where the hooks for adding adding inputs is, and where you can start the computations from. However, defining the underlying zero-knowledge computation is done in the ZK compute. So in here, we can now add our a struct which will be our input side.
Yeah, and if you want to sum it up a bit more, the contract versus ZK compute files, the contract is basically what you see in browser, what you interact with, the action you want to change, or if you want to increment a number in the public state. Whereas the ZK compute is actually the instructions for how to calculate anything on any node within our MPC calculation here. Exactly. So those are the instructions for handling the computations when we ask for them. So they are kind of more the hidden computation that no one needs to understand anything about besides the computation part of it.
Exactly. So now we have added our secret input. The secret input contains the salary, which was the same as before, and secret binary integer of bit size 32. And we have also added a gender choice of an SB 8-bit integer.
Yeah.
Yes.
Words are difficult.
So now we are defining it to be the secret type that we will allow to be inputted. And we're also saying it here for our input definition that the ZK input is the type that we should use. Good. So now we have defined that we are actually using a different form of input. So over here in our computation, we cannot just we cannot just read out an SBI 32 anymore, because it's actually not an SBI 32. It is actually our ZK input. So what we will need to do here instead is we will need to define, we will actually need to load up our ZK input instead, such that we have this, and here we could then say reported salary. Let's just say salary, so we can actually access the field we have. But right now we're just doing the same as we had before. We're not doing anything based on the gender. So now we would like to have some form of structure such that we actually know when we are summing for the males and when we are summing for the females and so on. So we are actually summing for the correct results. So to do that, we can define something like our a struct, which would just be our gendered sums. Gender sums. And in here, we'll just define here we will just define that we have two fields. We have all of the salaries that have been summed, where there will be free, one for each of our options. And then there are the counts of each, how do you say, gendered input you have. So a male count and a female count and a other count. So in this case, let's call this.
So what Jens is trying to kind of say is that how can we understand what a gender is, which is a very polarized thing to say in these times, but it is to how do we understand it from a programming way of looking at it, right? So we need to understand that a gender could be numbers or something that makes it cheaper to do it. And in here we're doing at the salary sums and how we can work with that as a struct. A second objective of building the structs into the ZK compute is simply that it's just easier for us to code things when we build the structs this way. So we always recommend that you build your structs the same way from contract and ZK compute, because it just makes it easier for you to use the variables that you actually get when doing any ZK between these contract and ZK compute, as long as it doesn't, show anything it should.
Exactly. So I have I've just
copied in a lot of stuff. Why did we copy in a lot of stuff?
Exactly. So this is the struct I just talked about, which is defining the sums and the input counts. The sums are all of the salaries summed together. So let me just quickly.
And maybe we should explain the math itself for people who just don't understand how to do averages. If that makes sense.
Yeah.
That we talk about types now.
Yeah.
So we need a sum to do anything. So the sum of all salaries that got into, that's the first struct that we're looking at. So we need the sum versus how many people are there. Then we would need to understand how many of these salaries are males, how many of these are female salaries, and other salaries, I think, is an inclusive terminology we're doing here. And then we would need to understand how many males are there, how many females are there, and how many other counts are there. And it's simply to do the average, right? So the math behind it is taking the male salary and dividing that with the amount of males that has inputted salary.
Exactly.
And that's how we get the average, just for everybody to be on the same page.
Exactly. So now we need to define, just like we have here in this sum everything function, which earlier had the total reported salary starting from 0, then it summed all of it up, and then it just outputted the full sum. Now we need to define the counts, which are starting at 0, and also the sums which are starting at 0. So how would we be able to do that? Well, we can use a vector for that, for both of them. So here we have our sum salaries, again, sum salaries, and we have our input counts, 3 of each, which are starting at 0. Good. So now we need to branch in the case of for our genders, such that we are actually counting up in the correct places. So to do that, we need to still check that we have a variable of our salary. Just quickly, a reminder here, not a reminder, but a quick note here is the way we're actually identifying different variables from each other, the ones that have been outputted by a computation and the ones that are being inputted by people, is that we are using what is called the public metadata of the input variable. In this case, we are designating all inputs as salary variables. So the way that's defined is that we can see up here, we have a salary and we have a sum result, which is the public metadata we are sending along with it. So when we are adding an input in our add salary right here, we can see that we are sending along with the input that is being added, the metadata that it is a salary variable that is being added. Also, when we just now that we're here, when we are starting a computation, we can also see that the output metadata is linked to a sum result. So that means that the variable we will output will have the metadata of sum result. That means it will also not be used in a new average when we're using that. So we need to check that the variables we're using are of the correct kind that we would like to have a part of our average computation.
And we definitely need to explain a bit more about this, right?
Yeah.
Because what Jens is talking about is that we have some public metadata that you in the contract can define stuff that needs to be publicly available as part of the variables you're putting into a zero knowledge computation. And it is because the nodes that gets the secret shares, they know nothing about the data you're giving them. So sometimes you would like to give some public available information that the zero knowledge nodes then can report on and do stuff with. As an example, it would be saying, these results are from this calculation. You do not need to use these anymore, so we can do more of them. And if we didn't tell them about it, the nodes themselves, they would never be able to understand what was the first computation and what was the second computation. So we're kind of putting these blocks inside our variables to kind of identify them in a way that we don't share the secret, but we share parts of the computation steps that is part of the contract itself. So it just makes sense that, of course, we want to know what was the first computation and the second computation. There is no secrets in that. That's just a system choice we need to do. Otherwise, we will not be able to reuse the contract that we're deploying.
Exactly. So now we need to make sure that we are incrementing the right indexes in our to list. because we made two lists here, which has three elements, one for the sum and one for the count of inputs for the gender. So for each variable that we have that is inputted, we would like to have, we are checking that they are actually a salary input. Then we load that input into our type as the type we have defined above. So that means it has two fields, the salary and the gender choice. Good. So now what we can do is we can go over all of the possible choices of gender. For in our case, it is 1, 2, 3. And then we can check if our input's gender choice is equal to this identifier +1. So we are just checking. We're actually asking, are you a male? Okay, no. Are you a female? Okay, no. Are you other? Okay, yes. Great. Let's add your salary and increment the count for others. So that is what is happening right here. We add the salaries and we increment by 1 for the counts. So this is all great, but now we also need to output all of these numbers so we can actually have the counts and the sums for these gender choices for us to then have to be able to compute the averages afterwards. So to do this, we will define, we have defined our output type, which is our generated sum output. So we just create our struct where we insert all of the values for it. And this. So. Oops. So the reason I'm getting an error here is because I'm not returning what our function is actually expecting us to return. So I just need to change it such that we are actually returning the type
that it expects.
Function. Yeah, it actually expects.
It's a Rust thing.
It's a Rust thing. But we now have a computation which is actually going to compile, hopefully. But we are now outputting something different than our salary earlier, our sum average. So for us to actually understand that when it is outputted and added to the contract state, we need a way to have a public representation of the output. Because what is actually outputted is the secret type, but then that is recombined back into our public types. So what we need to do is actually create a public representation of the
of the results.
Yeah, of the results.
So we need to publicize something about our survey here of the average salary, and we have decided that we would like to publicize the average of each gender salary.
Exactly.
And that's what we need to define. Otherwise, it would be a jumble of numbers we've asked it to just do, right? It would just be some bytes we would get that would be non-necessarily translatable unless you understood what the recipe was. So we're just trying to combine that into something that actually makes sense when looking at it.
Exactly.
Which is a start.
Exactly. So what we're going to do is we're going to have our just a public representation of all of the types, once again, just defined at the top. These are exactly the same as the ones we had in, well, they're not exactly the same, but they are the public representation of what we had in our ZK compute file. You can see the only difference is the secret binary integer versus our integer with I32.
Which goes back to the point that we often recommend that you actually do use the same structs in both the public and non-public part if they're not giving away any of your secret data or secret input, simply because the struct just makes more sense, and these are not put online anywhere. The contracts are not readable as is when you deploy them to the contract.
And it also doesn't matter because this representation is just for us to actually read the outputs of the computation, which is already going to be public when we open it. So that is still allowed, but it's not going to reveal anything about the inputs that we're giving. Now I'm also just going to add one more struct, which is just going to be our result that we're going to save in our state. So instead of just having an U32 integer, I'm going to have our general averages used here. It is just 3 values of I32 we're using.
So it's just 3 numbers.
Yeah, it's just 3 numbers, but it's averages which has been computed secret. So that's very neat.
So they are awesome numbers.
Yeah, they're awesome numbers. Good. So what would we need to do now to actually have all of this work? Well, first off, we need, this is still the same, it's going to output the same. However, here, when we are opening the values, we are not just opening the U32 anymore. Because the open value is going to give us our secret variable, and then we now need to deserialize it into a known struct, which we can then use. So to do that, we have to change the read variable we have right here, so we can actually read our gendered result instead. So we would like to have our gendered sum result as our output. So how do we do that? Well, we can actually do quite we can actually use the types we have defined to help us. So what we're going to do is we're going to send along a set case state first of. Oops. We're just going to add the set case state. Sorry about this.
So Jens is taking some of his cookbook.
Yeah.
Clicks here.
Yeah, exactly.
And maybe we should go through the line by line.
Yeah, exactly. So, but I am going to do that. But
yes.
Just quickly going to make this.
So you got to remember, Jens is a developer, and red lines are hurtful.
Yeah.
It hurts the eyes and the soul, so that's why they need to be fixed first.
Exactly.
So what you're doing here is shaping up how to represent the data, how to actually grab the secret data from the nodes and showcase it in the state.
Yeah, exactly. Good. And now we just need to say that variable ID. Great. So what is actually happening here is that we are taking, we are opening a variable. So that is our result we are opening. We are getting all of the secret variables IDs. We can open more than one variable. So this can also be used for other cases, but in our case, we're only opening one variable. Every computation is going to open one variable for us. And that is why we also have this assert. But what we're going to do is we're going to get the open variable, and now we're going to read this open variable with the current function. So what this does is we are getting the variable from our zero knowledge state. That's the secret part of the state. That's the one that says, oh, we have an open variable here. Here is all of the values you need, so you can actually open the variable. It's to
allow for us to get the result.
Yeah.
Otherwise, we wouldn't get the result
exactly.
at any point.
True. So now we get our variable out. We're going to take the data, we're going to clone it, and we're going to unwrap it. So now we end up with a byte array. And this byte array, we can now use the state read from for our gendered sum result, which would then leave us with our result. So oh yeah, I just need to import it. Good. Yeah, great. So now we have our result here, but our result is not an average. Right now we are outputting all of the sums and all of the counts. So we need to change, we actually need to create the averages. So what we're going to do is, instead of making this computation right here, which is just a normal average, we're actually going to just quickly delete this. I'm just going to, yes. Oh. And now we're going to create our averages. Oh. So this is also from my cookbook, but what we can see here is that we are just taking our gender averages and creating an instance of it where we are computing each average salary for each gender. But see, I have defined a specific function here that ignores the cases where there are no inputs for our average salary. So we are trying to divide by 0. Since we could be in a case where there are only male and other in a workplace, or female and other in a workplace.
Or just only females.
Yeah, or only males.
So it's to make sure we don't crash empty servers, basically.
Because division by 0 is not a great.
It's not a great thing to do.
So I just made a little easy function, which is just division where we ignore 0, where we have our nominator, which is 932, and our denominator, which is 932. And if our denominator is 0, well, then we just return 0. But if not, we do normal division. So
we do the math needed to create an average.
Exactly.
And why do we do the average calculation out here? It might be more logical for me to think we should do it in the zero knowledge computation.
Well, since we are actually sending in our gender in secret, all of the inputs genders are still in secret. So as long as we have a high enough amount of inputs for the different genders, these will actually conceal each other, and therefore we cannot tell anything about who gave what as an input. We can, however, say that we know the amount of one gender there is in a company. You can do division in secret, however, it is very expensive, since, that's a whole other talk.
So we need to think about what we actually send in.
Yes.
And where we actually do action sometimes.
Yeah.
And sometimes we don't need to do a secret action inside the secret parts of it if we can just eliminate the trace of the data itself.
Yes, exactly.
So that's just a good tidbit to know when working with zero knowledge. It's one of the confusions we sometimes see.
Exactly. So in our case, let's just quickly get the last part of it. So now we are actually,
So the last part is
just actually setting our result. So here we're actually using the averages we just calculated. We are setting our state to actually contain these. We are also just getting the number of employees, which is unnecessary, so we're going to delete that. And then we are telling the contract, you are now done.
Yeah, so again, to align across a lot of nodes and a lot of actions on a sharding model as our, we need to tell the contract which state do we change to when we do things, right?
Exactly.
So this is to tell the nodes, you have completed your task, you can stop doing things now.
Yeah, and also this is where you would just change it to not be done if you wanted to do a computation again sometimes later. However, the nodes are still allocated for you, and you are paying fees when they are allocated for you.
Yes.
Because they are actively protecting your secrets.
Yes.
So, yeah.
So that's why
now we also, all we have left to do is test that I didn't mess up somewhere.
And now the fun part comes. So just to iterate what we've been through for now, we've done the petition learning challenge to just show how easy it was to do anything. Now we've taken it to the zero knowledge part, and we did the first thing, which was increment the amount of inputs we got from a company to see how many people actually sent any things into the contract. And we've deployed that to the testnet as well. Now we're doing the third part of the challenge, which is to work with the secret data in a more in-depth way without giving away any of the knowledge behind it.
So I'm just quickly gonna try and deploy this.
So what we're trying to achieve is actually deploy the contract to the testnet. Again, we made a lot of code changes. Now we want to check, does it actually work on the testnet? Does it work on Partisia Blockchain as it is? And it seems that it should work right now.
It should work. Yeah.
So we've deployed it. We can see our status here. The number of employees is still 0. Now we've had the new contract out there. So this is the first deployable contract. I'll share the link as well. and then we could start inputting different pieces to it if we want to.
This is the contract address if you want to try to add your input. All you have to do is sign in with one of the private keys that you could have generated from the playground.
Yeah. So if you have any access to doing any interactions, feel free to go to the browser, click on the interact button, click on the add salary, and then add a salary. I'll do it as well.
And remember, the gender choice is 1 for male, 2 for female, 3 for other.
Adding my salary as well, so we should be able to see some inputs.
Boom. There are already 2 people. Guess who that is? But added our salary.
And if anyone else has any private keys, feel free. Maybe we could share one of our private keys. All right, so let's turn it a bit more over to the AMA. If there are any questions, feel free to send those now. Otherwise, I think I'll just send in a couple more private salaries. One of the questions, the first question I think we should answer was Mohit, who asked, how can I integrate Partisia Blockchain with my website that was created in React.js? And I think our answer to how you can integrate to Partisia Blockchain with your website is to first understand your use case. What do you need the blockchain for? What is your wish to integrate with? Is it a transaction you want to have a look at? Then it might be one of the clients you want to have a look at, so you can see how you can sign in on the blockchain, create transactions onto the blockchain. We have some example clients. I think maybe we should quickly visit those in the...
Yes, if you go to our open source library, which we make you with a quick link, and you go into our language folder right here, and then you can see our example clients. Right here are some different Java examples of how to do it, but we also have a full web client example of how to interact with it in TypeScript. If you were to use TypeScript, we also have in the playground 2 frontends which are written in TypeScript, where you can see how to create interactions with a contract, and you can also deploy the contract yourself if you just follow the steps in the tutorials. You should be able to get it up and running.
I agree. I'm also sharing the official documentation with a link to the client if you want to understand more. Let's see, I think there's another question from Ismalia, who first asked if you can only build with Rust onto smart contracts. And yes, you can only build with the Rust language on Partisia Blockchain as smart contracts, but you can integrate with a lot of other things and do a lot of things around the system in other languages. So it should be fairly easy to integrate with on other languages parts with the client or anything like we just talked about. And a follow-up question from Ismalia is, what kind of project are you guys expecting? So that might be a personal question. I don't think I can talk for the foundation or the Partisia thing, but at least what I personally expect would be projects that try to decentralize very sensitive data. I very much enjoy the digital citizens parts of MPC, that it can allow for citizens to exist and vote. I also very much look forward to a better maybe content management that could be more transparent for me to see. I think in my life it's somewhat difficult to find traces of where my data is being used, what I've consented to, and I think the blockchain Web3 area is very close to revolutionizing that I have the power to just see what I do and want to with things in a more integrated fashion across many more systems. So it becomes more of the global computer. Those kind of projects I expect to see building on Partisia at some point. I don't know if you have any highlights you've had personally of projects.
Good thing I'm not judging, but I definitely think one of the coolest things you can do with all of this is you can allow so much control for the user of their private data. So, like, what I would really like to see is a way of generating statistics such that the user's data are not exploitatory and they cannot be used in a predatory setting, ad-wise, using targeted ads. And just a simple example of letting people control their own inputs in it, but also only having, but only producing results from it, it would be incredibly nice to see.
Yeah, and maybe since you also said about the judgments as a part of the judging of the hackathon, I also think in general what we want to see is the inspiration tab for the hackathon. And I think one of the internal things we've talked about is how cool it would be to get some UI projects of this existing example smart contracts that we think are very to the coolness factor that you could build upon if you are not a Rust expert. I generally would like to see UIs being built on our example smart contract, which is a eligible submission you can do in the hackathon. And I'll post a link to the inspiration where all these different use cases and what we expect to be built during the hackathon is readily available. So I think we'll answer what Georgie, I hope I'm not killing your name, Georgie is asking. Is it possible to keep secret JPGs and MP4s for the purpose of a private social media / journal type use case? I think I'll throw it over to you, Jens. I think we worked with PNGs before at least.
Yeah. So there are different solutions to do such a thing. One of them could be that what you're actually doing is you are encrypting the data and then you're storing the encrypted data elsewhere. And then what you're using the blockchain for is looking into who is accessing the data in this regard. That is one way to do it, where you're like decrypting. Well, you're encrypting the data that is lying on the server, and then you're having the key secret shared between the nodes. So you have to open the input towards yourself to get the key to decrypt the PNG and the JPEG. I think your case is very interesting. Another way was one of the future extensions of the languages having just a big data. Well, maybe one of the future extensions of languages having just a big blob of data that has been secret shared, where you cannot actually perform any form of meaningful computation on it, because all it is actually just keep it secret until I would like to see it. Have it opened or access it in that regard from the secrets. However, that is a very long-term contract of lifetime. So I think the key part of it would be a better alternative.
You would have to look at other ways of storing the media and then making sure that that's the scrambled part of it, giving reference to it.
Yeah.
So I would think deeply about how I want to structure it, because it costs money to put things on the chain.
Yeah.
Right. And it can be hugely expensive to put large files on the blockchain simply because of the storage of it, as Jens is saying, right?
Yes.
So I would definitely look at another architecture at least than just putting everything on chain and be like, what other service could I use that with that, along with a secret sharing or hiding of the links to it, can be this social media part of it. So the architecture is very much needed to understand how much MPC is really needed for any given solution. It's one of the talks we have on our Medium as well, where our cryptography expert is talking about that you should, when looking at zero knowledge, only use the amount of zero knowledge that is really needed in the system, because MPC costs a lot of computation. So it is not a free to use computation.
Exactly.
So try and always think in architecture and in systems about the lowest amount of MPC you could use to achieve your goal, simply because you would like to, in any company, have higher profit margins or the best available code, the fastest response times, and all these things. And you get these if you just think about the least amount of MPC that you need to have in any solution. It's the same thing as we've just showcased here with the average salary, right? That, hey, we don't need to hide all these things. We're just hiding the things that are really needed, which would be the salary inputs, the genders, but we would not need to hide the computation itself, that it's being done, that this sum of things divided with these amount of participants, that's not the secret part. It's the individualized inputs from your public key that says, this is my salary, this is my gender, this is what we want to hide. And always thinking about along these lines when doing any architecture choice on the Partisia blockchain is hugely critical to any system you want to build.
And now we've talked about how we actually can compute these things. Let's try and start a computation now with the inputs that have been given by you guys.
So let's see what average salaries we have available.
What happened here? So now it should start. Hey, it started. So now we can see that our transaction went through on the browser. Right here. And now we can go into our contract. And here we can see, if we update, that we have now outputted. We can also see that all of the nodes have committed to the resolve. And now we have outputted it. And now we can look at our state, where we can see our average salary resolve, where we have 3 averages, which have been given by you guys, and which have been computed. We can also see that there are 4 people who have actually inputted.
Yeah. So we know from the amount of inputs, it's not.
This is not secret because we don't have enough.
Now we know what other one person might earn and what one other female person might earn. But we can at least see that there's an idea of a male average salary. So this is something we should have handled, right, in our contract. It would be good to make sure that you can't have an average below 3.
Yeah.
As an example, otherwise it would showcase some ideas. If our company was only 4 people, this would be very exposing of the other 2 gender, maybe even all 3 of them actually kind of very easy.
You need 3.
You would need 3 inputs, and this is something we could mask in our zero knowledge computation. And it's a perfect example of thinking about the inputs you want to have, and that it's also on us as developers and creators to ensure that the inputs and outputs are actually hidden.
Yeah.
The best thing here you could say is that you can't trace this directly to who sent what at what time.
Yeah.
So that's at least masked, right? That we don't exactly know that it was Jens and I doing the male average salary inputs. You might say you could know it now because we've stated that we did it.
Yeah.
But in that case, it would be kind of secret. Unless you knew our public keys and who we were, you would have an idea that we at least inputted to this one. And you would know that we would either be male, female, or other in this case. So I think it's a great showcase of how to compute things. Yeah, hey, so if you want to do anything through the hackathon or get access to us in general, Jens and I are available on Discord and all the dev support channels, or raise the tickets if it's personalized that you need to ask any questions. It's been a blast making this hackathon workshop, and if we get a lot of positive feedback, we might do more. The video will be posted on the YouTube, I assume, and it will be shared in according channels. And yeah, so if any other questions, anything is there, hit us on Discord. Feel free to grab us. I think Jens here is called JSN, and I'm just called Mike. So tag us in any questions you have, and have a really good day. It was nice.
Thank you.
Thank you.